Alright, so today's lesson is going to be all about multiplying and dividing radicals, alright? So multiplying and dividing radicals. So first, we're going to do multiplying radicals. Okay, so when we're multiplying radicals, well, remember from the last video that a radical was something in the form of a, the nth root of b. And we said a, the number in front, was called the coefficient. And b, the number underneath the radical symbol, is called the radicand. Okay, so when we're multiplying two radicals together, there's a few rules. So what you want to do is you want to multiply the coefficients together to give you a new coefficient, and you want to multiply the radicands. Okay, so let me give you an example. So let's say that we have, I don't know, 2 square root 3 multiplied by 3 square root 5. Okay, so what does that equal? Well, if we multiply the coefficients, so we're multiplying the 2 by the 3, which is what it said here to multiply the coefficients, then we get 6. Okay, then we want to multiply the radicands. So 3 multiplied by 5 is 15, so you get root 15. So it's basically just 6 square root 15. So that's it. Multiply the coefficients to give you a new coefficient, multiply the radicands to give you a new radicand. We may be able to do a question like this. Let's say if I just have root 2 multiplied by 3 root 5. Well, again, you multiply the coefficients, but this time there's nothing in front there, but we have to remember that when there's nothing in front, we assume that there is a 1. So 1 times 3 is 3, and then 2 times 5 is 10, so 3 square root 10. Alright, so that's it. So that's how you multiply radical. You may get a question something like this, where you have to multiply radical outside the bracket. So let's say if I have square root 2, open parentheses, root 3 minus root 7. Well, if same rules apply, we use the distributive property. So use the distributive property. So root 2 multiplied by root 3, we multiply the radicands together. So that's going to give us square root of 6. Root 2 multiplied by negative root 7 is going to give us a negative root 14. So you just multiply the radicands together, and that's it. Alright, so that's multiplying radicals. Well, dividing radicals is very similar. So let's try a couple questions on dividing radicals. So let's imagine that I had square root 10 divided by the square root of 5. Well, guess what? You do the same thing. You you divide the radicals. Okay, so 10 divided by 5. So this is the same as square root 10 over 5, which is just going to be equal to square root of 2. Alright, so just divide the radicals. You may have a number out front. So let's say if you had 10 root 20 divided by, 2 root 20 divided by 1 root, let's say 5. Well, that one's going to be 2, because 2 divided by 1 is 2 root 4. Alright? So how about if you don't have two radicands that are able to divide? In that case, that's called rationalizing the denominator. Alright, and rationalizing the denominator is a method of simplifying. So you may remember from the last video we did some simplifying. Well, this is another method of simplification. So imagine that I had 1 divided by square root of 2. Well, in this case here, this is not 100% simplified. It's not really proper to have radicals on the denominator. You can have radicals on the denominator, but sometimes it's necessary to simplify it and change its form. So what you do is you multiply by essentially 1. And what you're multiplying by is root 2 over root 2. So you multiply by whatever is on the denominator and multiply it on the numerator and the denominator, because everybody knows that root 2 divided by root 2 is just 1. So if I'm multiplying by 1, I'm not actually changing this expression. All I'm doing is just changing its form, alright? But it's still going to be the same value. So if you multiply fractions together, make sure that you multiply the numerators together. So 1 multiplied by root 2 is square root 2. Multiply the denominators together, root 2 times root 2. Well, we know because of what we did above that that's root 4, but that also simplifies to be root 2 over 2, because you know that square root 4 is just 2. Alright, so that's how you rationalize the denominator. Alright,